Good morning again. Keeps happening. Sun comes up, and I usually watch it come up. Distributed Control Systems. DCS is the acronym for a distributed control system. What is that? In the good old days, simply put, it was a set of computers working together to run a chemical plant in this case. A huge chemical plant. What at the time was classed a world-class chemical plant and was written up in chemical magazines across the globe. Tenas Chemicals Joint Venture was the original name of it, since been bought out and renamed, but that was an introduction to distributed control systems. There were two, because there were two chemical plants in the facility. They were inside an explosion-proof building because chemical plants. This was a hazard classified area, and the building was designed and built, including the air handling systems, to handle chemical warfare. That would likely be the fundamentals of some of the designs to the air handling systems, to the explosion-proof doors, into the halon dump system that would put out a fire in the control rooms. So this distributed control system at the time, one of them had 2,000 input-output points, 2,000 sensors out there in the chemical plant, sensing things, making decisions based upon those sensors, opening valves, closing valves, partially opening a valve, making sure it did partially open. If it didn't open to where it was asked to go, you would set an operator alarm, and maintenance would go out and take a look at that valve. Distributed control systems. So that is an architectural systems design consideration. It is the life that surrounds you is a euphemism, is a sequitur. Controls. This is something we try to bound things to keep them reasonable. Speed limit signs are part of a control system. If you perceive them that way, for better or worse. So the speed limits have bounds. You might be able to get away with 35 and a 30, or 75 and a 55, or not. Distributed control systems. This is a huge concept. So the first one I was introduced to, invited to come play with, got the privilege to work with, is a non-degreed engineer. Was a 3-layer system. It had supervisory controls. It had display controls. Each one a unique design function, integrated into other operations. Over years, decades of engineering. At some engineering design house, one was in Germany and one was in England. So they were there because we were doing commissioning and startup work. Distributed controls. So the computer design had supervisory. What was the 3 layers? The 3 layers were designed for failure modes. So this controls architecture, very designed, very methodologically designed. In these days, this was the days of RS-232 communications. Physical wires running between computers that they talked across. The internet was barely invented in those days. And it was a security risk as well. So this distributed control system was designed with layers. Oddly, the computer system that ran this came out of space agency research. This was the same type of computer that ran the space shuttle simulator. This was the evolution, the escape of this technology out into the wild of corporate world. So that controls architecture is a study in itself. It is very dependent upon what world you're in. You can consider accounting a controls architecture. There's auditing methodologies and procedures you're supposed to follow within accounting and accounting rules. Those are process controls. Those can be developed into human controls, as you're aware well of, artificial intelligence, IoT, Internet of Things, making old cell phones into new devices to just hang around so you don't have to throw your old cell phone away. Distributed controls. Decisions being made by computers. This chemical plant was designed based upon an operating plant in Asia somewhere. Might have been India. That plant required some 3,000 operators to run. And in Indian labor, that even adds up to money too. In America, this new plant required less than a few dozen to run. It required hundreds of people on staff, mostly maintenance people, to repair things. But the process controls took over people out in the field, opening and closing valves, making sure valves opened and closed, beating them with hammers. So this idea in the next evolution of these computers became parallel processors on a network called DECnet at that time, Ethernet. Clusters of computers making decisions, none totally dependent upon the others for their decisions. Parallel computers, time synced, so that if one fails, the other one picks up. This is failover technology developed not only for the space agencies, but for mostly weapons research, redundant systems, hardened systems, classical engineered systems. Problem is, engineering degrees might not get you very far. You expect a paycheck with those, and it's easier to hire someone around that, but that's a sequitur. So, distributed control system, huge concept. Why am I doing this?